Today we are going to be integrating using what's called U substitution. Okay, now it doesn't matter what the letter is, but most books tend to call this U substitution. And if you remember the chain rule, if we had d dx of f of g of x gives you f prime of g of x times g prime of x. So the idea here is if you look at your integrand, which again is the function inside the integral, and you'd have to do chain rule to find the derivative, then you have to do U substitution to find the integral. So, remember chain rule, we have something similar to antiderivatives. It is called, again, U substitution. Now, again, the letter is not too important. It's just most books tend to use U. So we just tend to stick with it. It's all kind of just became the norm, okay? Now, what that means is if we look inside here, we are going to replace that inside function, that g of x, function within the function, with a single variable. And that will make things easier to find the integral using your power rule or your inverse power rule on all that other stuff. So we are going to say that u is equal to 3x minus 4. So that means that we have the integral of u to the fifth dx. All right, but what is the problem we have right now? It's taking the integral according to x right now. We don't have x, we have u. So we need to replace that dx, and we need to have it be du. To do that, we are going to take the derivative of what our substitution du according to x. So what is the derivative of 3x minus 4? It is 3. And we are going to treat that derivative as a fraction. And we are going to get dx by itself so we can replace it with du. So to do that, multiply both sides by dx. So du is equal to 3 dx. And to get dx by itself, du over 3 is equal to dx. So now we have something we can replace dx with. So this becomes the integral of u to the fifth du over 3. Now, at some point, you're going to get pretty good at this because you're going to do this a lot. And you're going to skip some of those steps, okay? And that's fine. You don't have to do it. And I'll show you what I mean in a moment. So, since we have that du over 3, that is basically just 1/3. We can bring that outside the function as 1/3 integral of u to the fifth du. All right? Well, what is 1/3, or what is the integral of u to the fifth? Well, that is 1/6 u to the sixth plus c. So this is going to give you 1/3 times 1/6, 1/18. Now, before we're done, though, we use substitution. Our answer was the integral. Our question was, what's the integral according to x? So we do have to plug in our substitution back in. So since we substituted 3x minus 4 for u, we put in the 3x minus 4 back in. And there is our integral. There is not a way to do that without the substitution. Unless you want to raise that to the fifth power and then do the integral. You would get the same answer, but my goodness. All right. Anybody here know Pascal's triangle? It's the only way you could get that done quickly. So. All right. Any questions? All right, it's not too bad right now. Right. Now, when we do this, when we do use substitution, we are eventually going to take the derivative to u, which means we cannot have an x remaining in the integrand. So generally, when you do the u substitution like this, the x will eventually go away. Now, there are times when it doesn't, and we'll have some special rules of what to do with it then, but generally the x will go away. So, for example, if we say u is equal to x cubed plus 4, right? Now, here's the step I'm going to skip here. I'm going to skip this step and just do what's the derivative of u equal to, what's the derivative of this? 3x squared dx. All right, so that's what most people tend to do, is just to write it like that. And then we get dx by itself by saying this is du over 3x squared equal to dx. And some people even skip down to this. We'll go from here to here, and that's fine. Basically, what you're going to end up with is du over the derivative is equal to dx every time. So if you want to just skip from here to here, that's perfectly fine. Okay, I'm not going to be looking for that middle part. I will be looking for the beginning, and the du over the derivative is equal to dx. Okay, so again, basically it's going to be du over g prime of x equals dx every time. All right, so we substitute, integrate. U is that, so we have 6x squared u to the fifth dx, and we just did the substitution we can substitute that in. We get integral of 6x squared u to the fifth times du over 3x squared. So the nice thing is, what's happened to the x squared? Zoom in so we can see it a little better. What happens to the x squared? It cancels out. And even the 6 and 3 reduce, giving you the integral of 2 u to the fifth du. Now that 2 we can bring out just as well. 2, come on. 2 integral of u to the fifth. And we've already done u to the fifth du, which gives you 2 1/6 u to the sixth plus c. Now, why do we not care if the c is multiplied by 2? Why don't we write 2c? Because it's a constant. If you multiply a constant by a coefficient, it still remains a constant. It won't have any effect on the value of the constant. So if we had to solve for the particular solution, it wouldn't matter if the 2 is there or not. Okay. So all of it changes what you would find the value for c is, but when you plug it back in the function, you would still multiply it by 2, which would give it back to where it is. So anyway, not that you have to do that right now. So this is going to give you 1/3, and since we substitute back in, x cubed plus 4 to the sixth plus c. All right, so for this next one, generally our substitution is going to be what's in the parentheses. Okay, so u is going to equal the square root of x minus 1. And again, I'm just going to go ahead and write this as du over the derivative times dx. Now the derivative of this is 1 over 2 square root of x. We've done the square root of x, the derivative square root of x enough. We should know it's 1 over 2 square root of x. I mean, honestly, we've done it quite a bit. Now that means we can write that as 2 square root of x du is equal to dx. Because you just multiply by the reciprocal. So integral of u squared over square root of x times 2 square root of x du. Square root of x goes away. We can bring the 2 out. So that's going to give you 2 times 1/3 of u cubed plus c. So that will be 2/3 of the square root of x minus 1 cubed plus c. So we're going to get to trickier ones and trickier ones as we go through here. So now let's look at this one. What are we going to substitute in for? We know the derivative of sine is cosine, so we could say that u is equal, don't write this down, u is equal to sine x, which means if we do that whole du over the derivative of cosine x times dx, is that going to cancel out the cosine in the exponent position? No. So that does not work. And like I said, generally, when we substitute in, we're going to be substituting what's in the parentheses, and technically all exponents are in parentheses. We just don't write them there because it'd be annoying to write it every single time. So u is equal to cosine x, which means du over the derivative, which is negative sine x, equals dx. So we integrate sine x e to the u times du over negative sine x du. Oh no, we already have the du. Well, the sine x is going to cancel, but it leaves a negative there. So we're going to have a negative integral of, that's gone, e to the u du, which is negative e to the u plus c, which is negative e to the cosine x plus c. Now, number 5 does get a bit interesting. Here, we're going to say what's in the parentheses is 3x, so u equals 3x, which means du over 3 is equal to dx, because the derivative of 3x is 3. All right, so we have the integral of cotangent of u du over 3, which we can write as 1/3. We can bring that out. But before we do that, what's the integral of cotangent? Do we have an integral of cotangent? We have an integral of cosecant x, cotangent x, but we don't have an integral formula for just cotangent. So what we need to do is rewrite this in terms of sine and cosine. So I'm going to bring the 1/3 out. Integral of cosine x over sine x. Cosine u over sine u du. All right. Now we have to do what's called a double u substitution. And since this is a double u substitution, we are going to use w to substitute it for. Now, we could substitute in for cosine x. Okay, we could substitute cosine x, but if we did that, we'd end up with sine x squared in the denominator, or sine u squared in the denominator, and so that's not going to work. So we're going to say that u is equal to sine u, and we take the derivative, that means dw over cosine u is equal to du. So then we have 1/3 of the integral of cosine u over u times du over cosine u, which cancels out. Now, what is the integral of 1 over u? Actually, no, not 1 over u. I said w, didn't I? W. What is the integral of 1 over w? We went over this yesterday, so it's not fresh in your mind. It is the natural log. So we have 1/3 the natural log of the absolute value of w. But what is w? Sine u. But what is u? 3x plus c. So yeah, they get a little fun. How are we doing? What are we feeling about this? You okay? So this is going to happen. You're going to do a lot of u substitution. Okay, a lot of u substitution. And this isn't even really the fun stuff that BC gets to do second semester. Okay, which is integrating by parts. Okay, that's what's missing. That's what we're going to do second semester. The 11, 12, and 13 lessons. Yeah. One of those is just integrating by parts. That's where it gets interesting. All right. Now, like I said, in most cases, the x will kind of naturally cancel out. But let's see what happens when x does not cancel out. So we say, obviously here, u is going to be x plus 1, which means if we take the derivative of x, we just get 1. So we don't even have to put the over 1. It's not really necessary. Okay? So when we replace everything in, we get the integral of x over the square root of u du. But x is still there. Okay? So what do we do if x remains? What we want to do if x remains is solve for x using this. So if we solve for x, we would subtract 1 over and say x is equal to u minus 1. And then we can plug that in. Integral of u minus 1 over, we'll write that as u to the 1/2 to make this a bit easier. So we know that we are going to divide each of these by u to the 1/2, which gives you u to the 1/2 minus u to the negative 1/2 du. So if you divide each of these by u to the 1/2, u to the 1 divided by u to the 1/2 just subtracts the exponent. 1 minus 1/2 is 1/2. And then negative 1 over u to the 1/2 is negative 1, or negative u to the negative 1/2. Then we do the power rule. Okay, add 1, divide by the new denominator. We get 2/3 u to the 3/2 minus 2 u to the 1/2 plus c. And then we substitute back in 2/3 x plus 1 to the 3/2 minus 2 x plus 1 to the 1/2. If you wanted to write these as roots, like square root of x plus 1 cubed and minus 2 square root of x plus 1, I don't really care. You could do that. It will not be good or bad if you don't. Okay, all that is correct. Be able to identify if it's a multiple choice question. Okay, so be able to, but you don't have to. It's a free response from me. All right. Now where it gets a little more fun. It's just every step more fun as we go. So why I did that. Okay. So what does this look like? Now, here's the question. Don't write this down. What would I substitute in for if I want to do u substitution? What would you automatically look at this go, I probably want to substitute u for what? U is equal to 1 minus 4x squared, right? So that means du over what? 4x, negative 4x is equal to dx. But negative 4x isn't in there, is it? We just have a 1 up top. What does this look kind of like? The arc sine, our inverse sine. Okay? In fact, if we rewrite this as 1 over the square root of 1 minus 2x squared dx. Okay, by the way, so don't write this. You can write that part. Right? Dots here, driving nuts. So if we write it like that, we can say that u is equal to 2x, which means du over 2 is equal to dx. So we have the integral of 1 over the square root of 1 minus u squared du over 2. Now that is the arc sine. Okay, so it's going to be 1/2 arc sine of u plus c, which is 1/2 inverse sine of 2x plus c. All right. Next page. Using u substitution on definite integrals. Okay. So, now, the key thought here is the fact that the bounds 0 to 2 are for x. So we do u substitution. Okay, what bounds for u? I'm sorry, not x. We have a t here. Sorry, t. It makes no difference, but there it is. It does have a t. So we'll say that u is equal to t cubed plus 1. So du is equal to 3t squared, which equals dt. So we would integrate, and we have t squared square root of u du over 3t squared, which again, that will cancel out. But notice I left the bounds alone. If the bounds 0 to 2 for t, what do you think I'm going to do to find the bounds for u? You're going to use the substitution to find bounds for u. So if u is equal to t cubed plus 1, that means u is going to equal, we'll start with the lower bound, 0 cubed plus 1, and u is equal to the upper bound, 2 cubed plus 1. So we're going to basically plug the bounds into the substitution. So that gives you 1 and 9. Now the reason why we do this is so we actually don't have to substitute back into our function the t cubed plus 1 at the end. We could just use these bounds and plug it in through u. It saves you a good bit of time. So that gives you, since we know this is 1/3, what is the integral of square root of u? That is 2/3 u to the 3/2 from 1 to 9. Now this 2/3 we can multiply out. 2/9. If I plug in 9, square root of 9 is 3. 3 cubed is 27. Plug in 1, I just get 1. So we get 2/9 times 26, or 52/9. And again, feel free to check your answer. Derivative from 0 to 2. X squared, second square root of x cubed plus 1. And then we take our answer, math, and write that as fraction, 52/9. So I think this right here should be like the biggest selling point for if you have your calculator, use your calculator. Okay? Instead of doing all this work, you would think, instead of doing all this work, if you have a calculator, you'd use your calculator. So, yeah. The 3/2, because this is u to the 1/2, and so when you add 1, you get 3/2. So we need that inverse power rule. 1 plus 1/2 is 3/2. And that's why we divided by 3/2, which if you divide by 3/2, you get the 2/3. Because we still have to integrate the square root of u. All right, last one. All right. How about you try this one? Take a moment, try this one, see how you do. So here, u is equal to sine x, which means du over cosine x equals dx. So that you will see that's going to cancel out. I'm just going to do that. And since u is equal to sine x, that means that my upper bound, my lower bound, sine of 0 is 0. And sine of pi over 2 is 1. So we have the bounds from 0 to 1 of the square root of u du, which again, what is the antiderivative of the square root of u? That is that 2/3 u to the 3/2 from 0 to 1. All right. And if I plug in 0, I'm going to get 0. So I get 2/3 times 1 minus 0, or just 2/3. Now, here's the thing, and this lesson and the next lesson are pretty challenging. A lot of stuff happens here. Okay. In fact, usually this lesson is actually 2 lessons in itself. We don't really do definite integration with u substitution at the same time as indefinite. Usually that's 2 separate lessons. But the College Board put it in 1 unit, so that's how we're following along with it. So we have if you look at your notes, the very last page of notes, what is 1014? Or sorry, 614. Yeah, it's basically, hey, what are all the techniques and all your techniques together? Okay, it's not really a lesson. So I'm thinking I'm going to save 610 to Monday. Okay, because it's also a little intense, and I want to make sure we have enough time for it. And since 614 is like, hey, just do all your work with a bunch of mixed practice questions. So 614 is really just mixed practice. All right. I will still give you guys a review on Monday as well. We'll go over the review on Tuesday, test Wednesday and Thursday. Okay. But yeah, I'm going to say 610 for Monday. So only 1 lesson today.